Hello everyone. Today we're going to be going into more detail about domain and range. Specifically, how to find the domain and range from the graph of a function. First, we want to talk about two kinds of graphs or two kinds of data, and those are discrete and continuous data. Okay, so a discrete graph is going to be a list of specific points. And this will often come in the form of a scatter plot or a table or a list of points. Continuous data is when there are so many points that we cannot list all of the exact points. For example, a continuous line that doesn't break. Okay, and now we'll look at a little bit more in depth at continuous functions and how do we write the domain and range of continuous functions. Okay, so when we list the elements of the domain and range, we're going to write them as compound inequalities. And remember, a compound inequality is going to be an inequality that has two different inequality signs. Okay, so domain is the x-axis, so we're always looking left to right when we're writing the domain. The range is y-axis or y-values, so we're always looking from down to up or from bottom to top of the graph when we're finding the range. So your domain is always going to be written in this form. A number is less than or equal to x, and x is less than or equal to a number. And just like before, when we were writing compound inequalities that were ands, we're going to start with the smallest number on the left and the largest number on the right. So the smallest number is going to be the leftward boundary of the graph, and the largest number is going to be the rightward boundary of the graph. And with the range, the bottom boundary is going to be the smallest number, or the downward boundary, and the upward boundary is going to be the largest number. So the downward boundary on the left and the upward boundary on the right. So let's look at some examples now. Okay, so let's look at the table in number 1. First of all, is this discrete or continuous data? We can see that this table lists a set of points. It lists specific points. So that means that this is discrete data because it lists a set of specific points. Now we want to list the elements of the domain. So the domain is all of the x values. So we're just going to open up some squiggly brackets like this, and we're going to list from smallest to largest every x value. So -4, -3, -2, -1, and 0. That would be our domain. The range is the y values. So again, we're going to use set notation, which is these squiggly brackets, and we're going to list all the y values from smallest to largest. So that's our domain and range of a continuous or discrete function. We're going to skip number 2 and go back to that at the end. So let's go over to number 3. Is this a discrete or a continuous function? Again, we have specific points that are listed. Here's our x values, and here's our y values. Negative 1, 4, 4, 9, and 8, 13 would be the ordered pairs. So since this is basically a list of ordered pairs, this is a discrete data set. The domain is all of the x values, so we're going to list the 3 x values in set notation. Negative 1, 4, 8. Range is y values, so we'll list all of the y values in set notation. 4, 9, and 13. Okay, let's go to a different kind of representation. We can see that this graph here is a line that doesn't have any breaks in it. So this, we could say that this is a continuous line. So this data is continuous. So the domain is going to be every single x value that's included in this graph. So for the domain, we're going to be looking from left to right. And remember, when we write our domain, it's going to be written as a compound inequality. Our leftward boundary, or our smallest number, goes here. Our rightward boundary, or our largest number, goes there. So what we want to do is we want to find the smallest x value that's on the graph. So I'm going to start on the left, and I'm going to draw a line to make a leftward boundary of the graph. And I'm going to see where that line touches my x-axis. Okay, well, this line is going to touch the x-axis at x equals 0. So 0 is our leftward boundary. Remember, domain is left to right, so we're going to go all the way over to the rightmost boundary on the graph. And we're going to draw a line. And we're going to see where that line touches our x-axis, and that's going to be the rightmost boundary. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So our domain is all x values between 0 and 9. Okay, range is from bottom to top of the graph. I'm going to use green for range. So we're going to start at the bottom of the graph, and we're going to draw a line over to the y-axis, because range is y values. We're going to see, where does that line touch the y-axis? It touches the y-axis at y equals 0. And again, we're going to use a compound inequality. So our bottom boundary is 0. And now let's find what our top boundary is. So we go up to the top point on the graph. We draw a line across to where it touches the y-axis, because range is y values. And we count up to see what that y-coordinate is. 1, 2, 3, 4, 5, 6, 7, 8. So our range is all of the y values between 0 and 8. And it's also going to include 0 and 8. That's why we've used the equal to in our inequality sign. Okay, let's look at the graph in number 5. First of all, is this a discrete or a continuous graph? Well, if we look at the graph, we never see a break in the line. So this is going to be a continuous graph. The domain is going to be all of our x values. And we write it as a compound inequality. So since it's x values, we're looking at the graph from left to right. And let's use orange again. So we want to draw a line across the leftmost boundary of the graph. And we look to see where that crosses the x-axis, and that's going to tell us the smallest number in our range. So that's -1, -2, -3. Now we're going to draw a line across the rightmost boundary of our graph. And we look to see where that line crosses the x-axis. 1, 2, 3, 4, 5. So the rightmost boundary of our domain is 5. So our domain is all values of x between -3 and 5, also including -3 and 5. Range, we're looking at the graph from bottom to top or from downward to upward. So we'll start at the bottom of the graph. Okay, this green line crosses the y-axis at -1, 2, 3, 4, 5, 6, 7. So the bottom boundary of our range is -7. Let's find our top boundary. Our top boundary is going to be 1, 2, 3, 4, 5. So our range is all y values between -7 and 5, also including -7 and 5. All right, moving on to example 6. First, let's identify what type of function this is. We notice that between these 2 points here, the function is unbroken. It is a continuous line, so this would be a continuous function. And now we want to identify the domain and the range. Now notice that both of these dots are open. Okay? This is like having an open circle on a number line, and remember that that meant that this point is not included in the solution set. So we're going to indicate that by using less than signs in the domain and in the range instead of less than or equal to. So we're leaving out the equal to that is sometimes underneath the less than sign because the circle is open. So now we want to find our domain. So we want to find the left boundary. So we'll draw a line along the left of the graph. And we see that it intersects the x-axis at -1, 2, 3, 4, 5. So the left boundary of our domain is -5, and the right boundary of our domain is 4. So this function goes from -5 to +4 on the domain, but does not include the endpoints. Now let's look at our range. Range, we're always looking from domain is left to right, range is bottom to top. So we'll start at the bottom of the graph and find the downward boundary. So since range is y values, we'll look at where that crosses the y-axis, down 1, 2, 3. So our downward boundary is -3. And by the way, is the y value of -3 included in the graph? Well, since the graph is continuous right here, since there's no open hole in the graph, we would say that yes, -3 is included in the graph. So we have to add the equal to under the less than. Now let's look at our upward boundary on the graph. So our upward boundary for y is 1, 2, 3, 4, 5, 6. So is the y value 6 included in the graph? Do we need an equal to? Well, we know that it's not because we have an open circle on both sides of our graph, so that would mean that the y-coordinate 6 is not included in the graph. Okay, let's go to our last example. We saved this one for last. This will be a continuous function because we don't see any breaks or holes in the line. Now let's figure out the domain of the function. Now when we're trying to find our boundaries, when we're looking from left to right, we are not going to draw a boundary that would touch an arrow. So if I go over to this side of the graph, I notice that if I were to draw my boundary line here, it would touch an arrow. So I'm not going to draw in the boundary line because this arrow means that this line is continuing out and out and out, further and further out in the negative direction on the x-axis. So this is going to mean that there is no boundary on the left side because this line is continuing. So we say that the boundary is negative infinity. Okay, this little sideways 8 means infinity. Now if we look on the right side of the function, if we were to try and draw our boundary line would touch an arrow. So we're not going to draw in the boundary line because this arrow means that the function is continuing further and further and further out in this direction until it goes to positive infinity. Another way of writing this domain is to use this kind of a funny shaped R. It's like an R with two stems on it, and it means all real numbers. So we can write the domain as negative infinity to positive infinity, or we can write the domain as all real numbers. Okay, let's look at the range. So range goes from bottom to top. We're looking at y values. So if we try to draw a line along the bottom of this function, our line would touch an arrow. So we're not going to put a boundary line in there because these arrows tell us that this function is going to continue to go down and down and down. So our downward boundary is negative infinity. Now let's find our upward boundary. We don't have any lines on the top of the graph, or we don't have any arrows on the top of the graph, so there is an upward boundary, and the upward boundary for our range is going to be 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the largest y value on the graph. So another way of writing our range would be to say that y is less than or equal to 8. And by the way, we need to put an equal to under this less than sign because this point right here is a closed point, or there's no break in the graph at that point. So that means that the y value 8 is included in our solution. So there are two ways to write our range. We can write it as negative infinity to positive 8, or we can write it as y is less than or equal to 8. Okay, see you in class on block day.